In this example, we will take a look at reducing part weight of a mounting bracket by redesigning it with the help of the all-new Topology Study that was introduced in SOLIDWORKS Simulation 2018. Topology Study, in summary, takes the maximum design space of a part and removes non-critical material to create an optimized design that accounts for all the applied loads, fixtures, and constraints. Let's go ahead and take a closer look at this trackaway assembly to find the mounting bracket I will be redesigning. Within this assembly, we can see a sliding table in the kitchen and dining area that was specifically designed for a motorhome. This table is currently rated to hold up to 50 pounds. This is the type of information we can use in our topology study to get more accurate results. Underneath this table, we will find the mounting bracket that is attached to a track assembly which allows it to slide back and forth. The goal of this study will be to reduce the mass, and the current mass of this part is around 5100 grams. It's always a good practice to start the topology study with the most allowable material within the bounding areas, as it gives the topology study tool the most freedom for material removal and distribution. We typically call this the block design. Using configurations, I am able to easily toggle between the original design and the block design. To set up the topology study, simply select on the new study icon, select topology study, and hit the OK. The setup for a topology study is very similar to a linear static analysis. As the material was already defined at the part level, the material is automatically defined here as well. To fix this part, I will choose the middle cylindrical pocket and select fixed geometry as the boundary condition. Next, I will define the force load as 100-pound force between these four faces. And to evenly distribute the force, I will apply this as a total load of all selected faces. To map out an optimized shape, Topology Study uses goals and constraints such as finding the best strength to weight ratio, minimizing the mass, or reducing the maximum displacement of a component. It is recommended to always start with the best strength to weight ratio to get an initial optimized shape of your component. For this example, I will attempt to reduce the mass by 90%. In addition to goals and constraints, manufacturing controls allows users to set up parameters to control material removal for final form and function. Preserved regions can be selected to be excluded from the optimization process. Specifying demold directions, thickness control, and symmetry control will further constrain the geometry to ensure that the optimized part is manufacturable. For this example, I will select a few areas to preserve, which are the four corners where the bracket is attached to the sliders and the mounting hole. We can also select depth of the selected faces to ensure we have suitable amount of thickness preserved, and this can be previewed by selecting on this geometry preview. At this point, I'm ready to run the analysis and view the results. The material mass plot shows the areas that are safe to remove and areas that must be kept. Using the slider bar, we can then slowly peel away the geometry that is okay to remove and only show the final optimized shape. Furthermore, you can also select the Calculate Smooth Mesh option to give the final shape more geometry definition. Once you're satisfied with the new optimized model, you can then export the smooth mesh as either a graphics body, solid body, or surface body, which you can then use as a template to create your new model. Using the 3D CAD tools available right within SOLIDWORKS, we can start to model up the final part. A quick weight check shows the new part is around 4000 grams, which means we were able to shave off more than 1000 grams of this part. As all these changes were made within configuration, I can now easily go back to my table assembly and toggle to my new redesigned part.